Okay, now here we are with section 7.3, and this one is still volume, but now just another way we could build and model the volume is this thing called the shell method. And the basic idea here is, think of a soup can and just the side part of it, that if I cut that material, I could lay it out as this nice rectangle. So if this is height and that's radius, well, then what I know is I have height here, and the radius r is the radius r ends up making this width 2 pi r, because I know that's the circumference. And so the area here is 2 pi r h, like that. And then to get a volume, I just need that thickness of the metal. So I've got my soup can, and when I roll it out, it'll have some thickness here. And so the volume is going to be 2 pi r h, and then times that small width or thickness or whatever, so I'll call it a w. So there's w. Can't really read it, can you? There's w. And so typically on these, our w is going to be our delta x or delta y, something like that. We're always going to have the 2 pi r, but the h is probably going to be our f of x. Something along those lines. We'll have to figure out r as we look at it. That may be x, actually, so we'll always have that 2 pi r, but that x, r might be x. And so we'll just see how all that fills in. But again, this is the idea with the shell method, is we're just going to add up lots of these tin cans. So, right, I could, if I had a bigger volume, I'd have a little hollow tin can, no top or bottom. I'd have that one, and then around that one I'd have another one, and around that one I'd have another one, and so forth. And I'd add up the volume of each of those little tin cans, and once I've added all those volumes together, I get an answer. So again, it would be a sum, and I would have a 2 pi, ri, hi, and a delta, I'll call it a delta xi, or a width I. And again, often the radius will come from x, so that'll probably be an xi, and often the height will be f of xi. And so when we sum this up, I equals 1 to n, we let delta xi go to infinity and so forth, we'll end up with some integral, a to b, and it will probably take on a form that looks a lot like 2 pi x times some f of x dx. We'll just have to see. Again, that r might be some function of x itself, and the h might be some function of x other than just x. But that's what we're heading toward in this section. So that's the shell method.